Welcome back to the universe. So today I wanted to look at tidal forces, which I hear are in the game and might be kind of cool to see in action. At the moment I've got up a Earth and Moon system, and this should be a pretty accurate representation of how far away the Moon is from the Earth. And so what are tidal forces? Well, a tidal force is essentially the impact of a larger body, say the Earth, gravitationally on a smaller body that's orbiting around it, say the Moon. So the Earth would exert a stronger gravitational pull on the side of the Moon that is facing it than on the side of the Moon that is away from it. And this would set up sort of a potential or a difference across the Moon in terms of that gravitational force. And if that tidal force is strong enough, it can affect the Moon's rotation. It can cause stress within the Moon, which would heat it up. And if it's large enough, it could actually rip the Moon to shreds. There's a certain point where these sort of tidal forces would be enough to rip another body apart, and that's called the Roche limit. So if the Moon was to be a lot closer to Earth and within the Roche limit, we would actually see the Moon being ripped apart by those extreme stresses that are gravitationally sort of exerted upon it. Tidal forces are also what have kind of locked the rotation of the Moon, in the sense that there's always one side facing us, or the same side, and that the Moon rotates on its axis almost the same amount of time that it takes to go around the Earth. So tidal forces sort of, they do have an impact on orbits and rotations of other bodies. Now, what I want to do is move the Moon closer, and we already have a simulation where we've got this Earth and Moon close, and see what happens if we are within that limit. This is at 20 minutes a second. Slow it down a little bit. So you can actually see it getting really hot, kind of rocks flying off it. Well, we're on the dark side now, but yeah, the Moon is definitely feeling a lot of stress from being this close to the Earth. And well, the Moon did used to be a lot closer to the Earth, and I don't think this is something that we're going to have to actually worry about in the future, because the Earth, I think, is moving very slightly further away from the Earth every year and not closer, so we're not going to suddenly run into this situation. I wonder if these smaller moons will then start to break up. Oh, that one's already starting to go. So I guess that's as it's decreased in size, it's still it's gotten closer, and it's still got forces on it such that the force of gravity from the Earth is stronger than the force of gravity actually holding this blob together in the first place. And so yeah, it's just imploding. I know we can have a look at a simulation with more than one close moon. In fact, we can look at Earth with 8 sort of satellites around it. So these little moon-looking things here are 8 copies of the dwarf planet series. Some of these are going to be close enough to be within the Roche limit, and we'll probably see them implode as well, but some of them might be lucky enough to escape that. So we're going 20 minutes a second again. As well as affecting things like orbits, destroying things, affecting like sort of rotation and what we see, these tidal forces can also affect planetary atmospheres and sort of the temperature of a planet, because before it implodes, or you even saw in that last simulation, the Earth was sort of heating up quite a lot, and these fragments are going to be getting quite hot as well. So I think you can try to consider things like tidal forces in terraforming a planet, or in trying to work out maybe something's really far away from a star, but maybe it's got enough tidal forces acting upon it that its temperature is not negligent. Well, those were some of the pre-made simulations, but I think we want to get a blank slate now. And I want to see, obviously tidal forces you're going to see on any massive object, so that should apply for the Earth, it should apply for stars, but also to the most massive thing I can think of right now, and that would be a black hole. Well, we can have Sagittarius A. I think that's the black hole, pretty close to us, or at least it's the only one I know by name. Anyway, we're going to add a few objects here and see how they're affected by the tidal forces. So let's put our sun in here. Put him at that sort of event horizon level. Yeah, and maybe a few further out. Let's see. Not sure how far we need to go to see no effect. I think all these suns are going to start to orbit the black hole. Hopefully some of them will survive spaghettification. Okay, alright. Well, I'm not sure what kind of timescale I'm going to need to see anything here, but let's just click play. Okay, immediately we're getting ripped apart here, and it's happening to everyone except this guy. So it's a really cool sort of interstellar-like simulation of this black hole here. Alright, let's go to our closest sun that was kind of at that event horizon distance. Well, I mean, some of it still exists. We didn't run for very long. We'll move back down to like 20 seconds per second. And play it. Okay, yeah, so it's getting stretched, it's getting like the material ripped from both sides of it, and it's just having that done while it starts to orbit around that black hole, and looks like a similar story. The sky seems to be alright, not sure for how long, but for now he's good. Alright. So even the sun is not immune to tidal forces. We can ramp that back up. So it kind of seems like some of these suns are actually starting to look less bad. Like, let's go have a look over here. That's no longer spaghettified. It's seemingly still called the sun. I don't know how, excuse me, how do I open this? There we go. I'm guessing it's lost quite a bit of mass though. Okay, so it's now 127 times Jupiter. I mean, that seems smaller than what we started with. Let's have a look over here. Okay, these masses actually come down to quite small. These are just listed in terms of kgs now, so actually they still look vaguely sun-like, but oh yeah, they've lost a lot of mass in this process and they are just getting ripped to pieces. Even this one out here, 462 Jupiter. I'll put back down another sun just to see what that would have said initially. Okay, and that gives it in terms of just one solar mass. So everything here is starting to lose mass as it orbits this black hole. I guess it's going to slowly dwindle down to just be a fragment. While they're off to their doom, what else can we add in? Well, we've got plenty of other stars. I wonder if these are rated by mass. Is this one a lot bigger? Actually, he's only an amount of Jupiters, so given by the fact that he's already obliterated, I don't think he was much more massive. Who is more massive here? Who do we have? Alright, Sirius is 2 times the Sun. 21 times the Sun, Rigel. 11 times. Let's go with a Rigel. Put Rigel in. Just put him in here. Okay, he's pretty big. I put him pretty far away. Let's see how he's affected by this. Oh yeah, okay, that's pretty cool. He's being, whoa. Okay, he was obliterated in a puff of smoke. Oh my gosh. Is that a nebula? Oh my god. Oh, there's one Rigel accidentally put down earlier. He's also being slowly obliterated. I wonder if we'll see a cloud of puff from him too. Okay, so what do we have all down here? Fragments, just fragments of Rigel. That's really cool. Our suns are still in there. Wow. Oh, so this is a supernova. There we go. So those tidal forces were enough to turn Rigel into a supernova? Well, I'll believe it if the game says so. That's pretty impressive. Wow. It's funny, like, isn't a supernova of a dying star one way that you can form a black hole in the first place? So I wonder if tidal forces from a black hole would be able to turn another massive dying star into a second black hole. I mean, let me know if you have any idea. Oh, let's just go full out with the Rigels. I want to see that supernova again. Is anyone heavier than Rigel over here? I'm looking. Sirius B. These ones look big. Okay, 260 of the Sun. That should be catastrophic. Let's put him in here. Okay. He's doing alright. He's doing okay. He's pretty far away, so again, it's a slow demise. What if we put him in a little closer? Well, at least I can see the black hole now since the sky is so blue. Oh, he's gone. Oh, here he comes. That's the supernova. Our old supernova is mysterious. Oh, there it is. There's our old supernova. And here's our new supernova. Many elements being formed in there. The dust that would one day become Earth, maybe this is the way it was formed. Really liking these supernova. Let's have a look at them. Yeah, so just really hot material. Alright, well, thanks for watching me explode some massive stars. using a black hole. Try this at home if you can. See you next time.